There are two kinds of knowledge that we technically deal with. One is called declarative and the other is, I classify it as declarative and procedural. Declarative is something like, Badri is speaking at this conference, right? So that's a declaration. It's a fact. Or this floor, the temperature now is whatever, 18, 20 degrees. It was much cooler a little while ago. So those are declarative, factual knowledge. Procedural is all the knowledge that has causal effect in it. Okay? So, for example, if something is done, something will happen. So, if you press the accelerator, the car will move forward. That's a procedural knowledge. It has a cause effect because factual knowledge is something that stays over time. Cause effect knowledge is what you use to change things. Cause effect knowledge is what you use to change things. If you want to decide that you want to reach a place in a certain time, you have to take actions. That means you will do things that will have effects, and the cumulative effects of these, one after the other, will help you reach your goal. Okay? So we need to capture this procedural knowledge. Now there are many things that people do with procedural knowledge. For example, you can verify systems. You can say, oh, if this is the cause effect, then I can model it. I can model the system which has certain cause effects, and I can say that, this system, something bad can happen. For example, if I let the system keep going without controlling it can get into a bad state. People also do simulations, right? We do this often. We write simulators to say, if the traffic came and if so much traffic came, then how much time later will the packet go out because packet processing takes so much delay, blah, blah, blah. So simulation is something we do with procedural knowledge. And the other part of procedural knowledge that has to do with doing actually is what I call planning. Okay? So planning is the part of procedural knowledge where we use the knowledge of cause and effect to derive a sequence of things to do. This is classical AI planning. No different. So these planning problems typically are called classic problems, or they are static problems, or offline problems. And I'll show you an example. What we'll see later is that this is not enough to do the kind of automation we want to do, and we have to do what I call reactive or dynamic planning. So here's a very quick intro to planning. There are courses on planning that run for a semester, but I'll just give you a very quick introduction. Here is a person that I'm calling an agent. So this gentleman here is an agent. And he's thinking, he's been given a problem. He's been given a problem. He's been told your table has 3 blocks. Please rearrange it so that it looks like this. So there is A, on top of it there's C, and then there's B, but rearrange it so that it looks like this. Okay? He's been given a problem. So he can change the table's state from this to this only if he does something. So knowing facts about the world is not enough, he has to know cause-effect relationships. Okay? So for example, he says, I will take the block C and put it on the side, take block B, put it on top of A, and then take block C and put it on top of B. No mystery here. Okay? So this sequence of steps that he has derived is something that I call a plan. So this is a plan. Plan is a sequence of steps. 1, 2, 3. 3 actions he did. That's called a plan. Plan got him from the initial state to the goal state. Oops. Okay. So what we can do is, since we are computer scientists and we want to put everything into the computer, we can say, here is a description or a language to describe the initial state. Here is a language to describe the final state. C is on the table, B is on top of A, and C is on top of B. A is on the table, B is on the table, C is on it. And here's a language, part of the language that describes an action called move. So this is the crux of procedural knowledge. It says there are some conditions, and if I do the move, I can only do them under those conditions, and it has a certain effect. Okay? There are some predicates that need to be true before I can take the action, and there are some predicates that are true after I take that. These are predicates are assertions about the world, statements. So for example, a statement about the world is A is on the table, B is on the table. Here the predicate B is on the table is not true here. Correct? Fair enough? So what I've done is I've formally written down whatever I have said informally. And what I want to arrive at is these actions. So that meet this goal. So if I did these actions on this state, I will get to this goal. These actions are derived from this procedural knowledge. So if I have procedural knowledge and I am given an initial state, I can reach a goal state. Okay? Now once I have made the plan, so I made the plan nicely. So what is the plan? Plan is here. So I tell the agent, look, I am a super planner. Okay? You give me the problem, I can plan for you. Okay? So I have planned. I've told the agent, boss, do these three things and you'll reach your goal. You'll achieve your goal. Fair enough? That's what a planner does. But now it is up to the agent to really do it. Okay? So it's good to think of planning as separate from actually executing. Execution takes the plan and does it. Okay? Now that seems a little trivial, right? Doesn't it seem trivial? Once you have the plan, it's done, right? What can be so interesting about it? You just do what the plan says. There are three statements, you just do those three statements, right? There's nothing to it, right? But now, for a minute, think that this agent is actually working in the real world. Okay, so there are three blocks here. A, B, C is sitting in this configuration and he has to lift it. Okay, and let's say he has an arm and the arm lifts and goes. So what can go wrong? So we told a child to do it. So my son is there, little guy. Simple, he does these three things. Can you please do this? Okay. And we ask the son, what can go wrong? Let's say he's a fairly intelligent guy. What can go wrong? So he follows the instructions, but something goes wrong. Maybe the hand fumbles. It's not unusual, right? Hand fumbles. Because why? Because maybe the block was not oriented properly. Some difficulty picking up the block. Or maybe after he put all the three together, everything fell down. Right? Often happens in little kids. Right? So reality of execution is influenced by many things, not just the plan that you have. Plan is like a template that if you did these things, you would achieve the goal. It doesn't mean you can do them. Plan is just one way of achieving a goal. It doesn't mean you can do that. So if we wanted to do something in the real world, right? If we wanted to meet our vision, it's not enough to do the planning, we have to do the execution. And this real world execution is actually real tough work. And if you want to automate things in the real world, if you want to go, we can tell the car, yeah, you have to start from this place and go to this place. All you have to do is stop at a red signal. I'll tell you when to turn left and right. No problem. And you say, go. You know it's not that easy, right? Because the real world is not completely modeled. Okay? Real world is not just about these actions, right? It's not just about move. I mean, it's about traffic signal will come and somebody will come in front of you. You never even thought about somebody else when this plan was made. Right? So real world planning for the real world can't just be done alone. You have to think about how it is executed. And so if I have a model of the world, I can model it and I can say, aha, I have a move action. Or in the case of driving the car, I have a signal, I will stop, I can accelerate, I can turn left, turn right, blah. And the planner will say, you've told me how this world behaves. That's the behavioral model, cause and effect model. Like move has a cause and effect. And I will tell you what plan to do. Right? That's what the planner does. And then when the person in the world is actually doing this work, he's executing, right? Then when he works, he just doesn't do what the planner does, he constantly senses the world. So the world doesn't give him the problem or the model, it also governs how he executes. Okay? So in real world, there are a lot of challenges. things happen in parallel. Many cars are going on in parallel. And there are unplanned states of the world. Right? For example, another car may come in front, or you're driving from Basangudi to Vidhan Sauda, and you chose to come via corporation, and they close the road. And you can't take that road, you have to come some other way, maybe on Silver or something like that, right? So there are many hazards that can happen which you didn't plan for, because that was not known at planning time. Right? And also things that in real life things take time. Right? So for example, you cannot say turn left and then turn right. You have to go a certain distance and turn. Then you cannot say turn left. Turning left itself is a time-consuming job. It doesn't happen instantaneously. So we need to deal with things that take time. So what we need to do is, we need to actually, when we execute the plans, we have the plan and we want to execute, but actually we need to do it by sensing the world, and in some sense we have to reactively plan. That is, we have to replan whatever we wanted to do. And so there are many approaches to dealing with this. So now planning is, if you are an AI student at some point in time, planning is not a very efficient. There are no very efficient algorithms for planning. It's very slow. If you take any problem and try to plan, and if there are 30 actions and many actions can be true in the current state of the world, and then you're in deep trouble. Your planning will not work. There are many planners available. You can try it out. It will take you an hour to get anywhere close to a solution. That's the way state of the technology is, and that's because the problem is inherently hard. So one way to deal with it is what we call the hierarchical approach, where instead of telling a person how to go from Basangudi to Vidhan Sauda, you say, hey, from Basangudi, get to Sajjan Rao Circle, then get to Corporation Circle, and from Corporation Circle get to Vidhan Sauda. So you give him 3 goals. You don't tell him which roads to take, but you tell him little things to do. So those are themselves little problems. They are themselves little goals. So you take the big tasks, instead of telling him exactly what to do, you say from initial state to final state, I give you 3 sub-tasks to do. So as long as you do those 3 sub-tasks finally, you're fine. Now that guy is very happy because the 3 sub-tasks are probably small. Right? This is a divide and conquer, like we do it always in life. Right? You have a big problem, you divide and conquer. So divide and conquer has a lot of value to it, and one of the values it has is that when you hit a problem, you only need to change your local plan. So if I have a problem getting from my house to Sajjan Rao Circle, I just have to find another way to get to Sajjan Rao Circle, and maybe there are not too many options. Maybe that's easy. So I'm trying to emphasize that 2 things, right? One is you need to do planning, you need to do reactive planning, and there are methods to deal with the scale of the problem. That's what I want to come on. And in real life, these systems are actually a bunch of people giving you data, and this data goes into the network somehow, because somebody has to look at the data, and he's not sitting at the place where the instrument is, and there's this huge cloud of people who are consuming the data, and so measurements could be made somewhere in this place outside the instruments. Some measurements could be made local to the instrument, but some of the analytics has to be done outside, and hopefully you can take action from that data. So the idea is that you get all this information and look at the measurements, and you're able to take an action. Ultimately, all this information is for you to plan, and plan is to execute. So data, analytics, blah, 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 plan, and then execute the plan. So execute the plan means what in our work we call this closing the loop. We want to close the loop from data to action. So you got data, you understood the data, you figured out what cause effects there are, maybe somebody told you what cause effects there are, you combined it with the data and you took an action. So you want to actually actuate. Okay? So if we do that properly, then perhaps we get a good network society that's actually sustainable, because you're not just generating data and putting machines out there, but you're giving them a lot of context, and you're giving them your goals that you want to achieve. So that is roughly what I wanted to talk about. Towards the very end, so I just want to give you a little bit about my company. So Ericsson has been in India for a long time, but my group is a research group, and Ericsson itself has these several areas. So You wouldn't be surprised. Ericsson is a telephone company, right? So radio networks or wireless networks or IP protocols and networking, these are all very common that you would expect in a telecom company. But my team works in two areas, cloud technology and the management of cyber physical systems or complex systems, large systems, right? So you can find out more about this if you go to our company. And something we're saying is that all the stuff that I talked about, large cities and stuff, all that is something we call network society. So if you go to Ericsson and say, tell me about network society, you'll see a lot of stuff that I told you about just now. If you want to know more, there are a bunch of workshops happening in Bangalore, so please take the opportunity to attend these workshops. They're happening all over the city. IEEE is sponsoring several of them. One of them, my team in Ericsson, so some of us got together and they're actually doing a workshop on Friday, September 4th. We'll be talking about planning, classical planning. We'll be talking about role of analytics, something called formal verification. I told you a little bit about this there. And advanced planning, the kind of planning that's really needed to deal with complex systems. So we'll have a bunch of speakers, so please do come and attend this. There's a bit.ly TA workshop link. Please take the opportunity to find out more. Also, I take the opportunity to advertise another conference that I run. It's called the HIPC conference. It's got nothing to do with planning, but I'm putting it there because two things. One is it has a student research symposium, so several people, I invite you to be part of that. And secondly, it has a special workshop on big data. So even though it's a high performance computing, they've understood that the data guys are important and stuff like that. And the third thing, of course, is it's in Bangalore. So not difficult. And of course, since you like pictures so much, I thought I'd show you another picture. This is our picture. All right. You want to take one more shot? What about this? So South Parade is MG Road. What about this? I don't know much of it, by the way. I'm guessing. So this says Higginbotham's and Co. So I'm guessing this is the Higginbotham building. There's still a Higginbotham's building there. But and I pass by it many days when going to office, but I'm still having a tough time connecting the two. Maybe it is that. So that's it. Thank you very much. We can take questions. So you can ask me anything related to this, or if you're bored of this, you can ask me other stuff as well. We have 5 minutes or 10 minutes? Okay.
December 16 to 20.
December 16 to 20. The student symposium is on 16. I think it's on 16th also. Big data workshop is also on 16th. So why do you think Ericsson as a company is interested in the kind of talk I gave? Why do you think Ericsson is a telephone company. What does Ericsson do? Does anyone know what Ericsson does? I found out a year ago because I joined Ericsson a year ago. They make mobile phones. Okay, they used to make mobile phones. They don't make them anymore.
Sony Ericsson.
Huh? Sony Ericsson. They used to make phones, but they don't make them anymore.
Software-defined networking.
Software-defined networking. Okay, good. Really good one. Okay. Anything else? What does Ericsson mean to you? So Airtel runs telephone network, right? Airtel telephone, Vodafone.
Networks.
So what does Ericsson have to do with that?
All the networking technology they utilize, I assume, is provided by.
So, for example,
The latest I could gather, they are working on software-defined networking only. They're developing virtual networks and all that.
So networking equipment means switches, right? Routers, switches. It also means you see these antennas that are put on top of buildings, right? They're also run by a company like Ericsson, either Ericsson or Alcatel-Lucent or some company like that. What else do you think they do? So they put a lot of networking equipment.
They might be developing some communication protocols.
Communication protocols, yeah, right? Okay, good. Okay, so one thing I learned, so I knew these answers before I went to Ericsson, right? So now I'll tell you of an answer I found out after I went to Ericsson. That's interesting. So when you get your bill, like Vodafone bill or something like that, or I don't know which of these companies Ericsson works for, so I'm just giving you an example. So let's say you get your Vodafone bill, and it says you're on the plan 199 or 500 or whatever, right? The bill generating software is done by Ericsson. So it's a lot. Ericsson is a huge software company, as big as it is a hardware company. So something that's not very well known. So there's a huge amount of software that goes behind or goes on top of all the hardware that a company like Ericsson puts in, right? For example, let's say you want to upgrade the software, everything is software, right? For example, the protocol that's running, they have some IP protocol running on each of these boxes. That's a piece of software. They have to change that, no? Because maybe you went from IPv4 to V6, or maybe an extra feature was added. It's a lot of software, so you need to push that software. So they need software that does the telecom. They also need software that changes the software on other boxes. It's a huge software company, okay? So don't think of Ericsson as telecom as just the hardware. There's a huge software stuff, right?
They do data analytics also?
They do data analytics. So for example, let's say the company is running Airtel's network. Let's say there's some company like Ericsson or Alcatel that's running Airtel's network, right? So how many phones? A huge number. How many base stations? That is those towers, huge number. Right? Backhaul network, that is, they are aggregated and then aggregated, and then they go to a central office where all the software and all that home locator, blah blah blah, everything is there. Right? Huge network. Each is a device. Add the number of devices, large number of devices. Now you have to manage these devices. Right? There's a